All right, good morning. My name is Isaac. This is Nate. We're here to do a quick update on the FSP 2.4 architecture spec changes and the current status for MIM platform and the activities going on there. So we'll do a quick overview of what they are, quick overview of the MIM platform progress, and then go through the FSP 2.4 features and wrap up with a call to action. So I hope everybody's seen enough of FSP today. Just FSP is our silicon blob, a binary blob for supporting open system firmware. MIM platform is a subset of our reference platform BIOS that's proprietary, that is designed to be open sourced and designed to work with the FSP as an enabling vehicle to enable whatever bootloader you choose. So you can go to tianocore.org, you can get our EDK2 MIM platform implementation, you can verify the FSP in API mode, dispatch mode, play with it, and then if you're going to core boot or any other bootloader, that path is there. And so it highly leverages our reference validation platform to ensure the quality of the FSP and the MIM platform. So it's there on the EDK2 platform as part of tianocore.org for Whitley. And we've got some activity with Rust ongoing, supporting that. We've got the Sapphire Rapids board port, the Gen 4 is in progress. So FSP and MIM platform for that will be available post-launch. We've got the AMI and MITAC Awanda Edge server was released in the last 12 months. So that's out there on tianocore.org that you can get and play with and get from OCP. That's an Edge server. The client Alder Lake FSP and MIM platform are coming soon. The Google Summer of Code had a bunch of projects related to tianocore and EDK2. And the one that's interesting here was a QEMU port to support the MIM platform architecture. And so this is an excellent introductory tool for the basics of how to build EDK2, how to get familiar with the system, use QEMU, and then from there you can go to the OVMF package, which is a very fully featured QEMU port in EDK2, or you can go to our reference platform, MIM platforms, if you happen to have an Intel reference platform for that generation. And so it's meant to be a stepping stone for learning your way through the MIM platform and the EDK2 and UEFI and Intel architecture products. We've had several production deployments ongoing now for a while. So MIM platform and Linux boot are in production and in use and going well. These are proprietary versions of the MIM platform, but they are out there. The concept is proven. We're able to reuse our reference platform content in a way that's open friendly. So that's great. And then for the next generation, after Sapphire Rapids, we have the MIM platform content fully integrated. So Ice Lake was the proof of concept, and it ended up going production. Sapphire Rapids is the maturity, and next generation is fully integrated into our reference platform. So the reference platform will be the MIM platform plus a bunch of binary extensions through the UEFI architecture. I'll hand off to Nate to talk about the FSP 2.4.
Hi, everyone. So I'm going to talk about FSP 2.4. So FSP in general has been a critical technology for OSF in general. Nobody has made a OCP checklist approved system without FSP to date. So
well,
really,
maybe the previous presentation changes that.
Well, perhaps, but at least as of right now, that stands true. So really, this project wouldn't exist without FSP, so it's critical to the ongoing effort here. So FSP 2.4 is the latest version of the specification. It's the largest change to the specification since FSP 2.0. There's many new features, and some of them have backwards incompatible changes. So that's really kind of what I'm here to talk about today, is what those are and how they impact existing OSF solutions. So the first is 64-bit. So we added support for x64 long mode to the FSP. So if the FSP is 64-bit, then we highly recommend that the bootloader around it also be 64-bit. It's possible to do some funny work with thunking in assembly language, but we don't really recommend it. So if the FSP is 64-bit, then you should generally have the bootloader be 64-bit as well. For core boot, that means that var stage, ROM stage, and RAM stage all need to move to 64-bit. For UEFI, that means SEC and PEI need to move to 64-bit. The next big change is support for system management mode. So we have a new FSP-I component added to the spec with a new entry point, FSP, SMM, and NIT, that enables us to basically take over the SMM environment from the FSP. So this enables us to do advanced RAS features that wouldn't really be possible without it, stuff like self-healing. So for example, in certain cases, we can actually correct a memory error without having to reboot the platform. But in order to do that, we need to have about half of our memory reference code in SMM running at OS runtime. So in order to make that possible, we need to have a way to put a binary into SMM so that we can put the MRC into SMM. So that's what this is all about. If the FSP-I binary is included in the FSP package, then bootloaders are required by spec to run it. And that means that the bootloader needs to disable its built-in SMM bootstrap. So what does this mean for the OSF? Well, for core boot, it means that the SMM module needs to switch to PECOF format and needs to implement the standalone MM SMI handler registration. For EDK2, we need to move from the traditional Dixie SMM to standalone MM. We've added support for MIPI SysT catalog debug messaging in FSP 2.4. Most people probably won't use this, but it's there now if you do. Here's the other big change, FSP variable access. So starting with FSP 2.4, the FSP can access a bootloader-provided non-volatile associative array. So in other words, key value pairs or a dictionary data structure in some languages. So this is used for storage of the memory training data instead of the existing design with the HOB and the UPD. The interface is very similar to the UEFI variable services interface, but there's no requirement to implement authenticated variables and no requirement for UEFI secure boot. It's just non-volatile data stored in key value pair format as opposed to just one enormous blob that comes in and then one enormous blob that goes out. So this lets us break the data down and only use parts of it at a time, which gave us a lot more flexibility because right now, even if we have a whole bunch of data that we don't need until later, we have to get all of it at once and then store all of it in temporary memory, modify it maybe, and then put it all out at the end, all in one big package, right? So this lets us break that package into smaller pieces so that we don't actually have to keep all of it in temp-RAM all at the same time, which is somewhat inefficient right now. So what does this mean for the bootloader? So for EDK2, you just need to implement the EDK2 PEI variable PPI. For API mode, we have a new FSP status variable request return code added and algorithm around servicing that request. So the algorithm for API mode access is more like a mailbox style interface. There's no direct function pointer invocation between the FSP and the bootloader. So all the problems that you might run into with that, like pointers being in a different memory address when you transition from temporary memory to permanent memory, all those problems are not really an issue with this design. But it does mean that there is this back and forth mailbox process that you have to implement in order to do it. And because of that, running FSP-M and FSP-S is not just as simple as running one API entry point anymore. So here's what the flow looks like. So I've used FSP-M as the example. FSP-S is basically the same. It's just replace a few of these labels. So you start out with calling FSP memory init. If FSP memory init returns the FSP status variable request return code, then you have to call a new API that we've added called get variable request info. This gives you back a data structure that tells you what the variable request was and what the FSP is asking for. The bootloader then goes services the request, whatever it may be. And then once the request is done, if it's a write, it tells it whether the write was successful or not. If it was a read, it returns back the data. So that is done through the complete variable request API, which is another new one that we added. And then once that's done, you check the status on complete variable request. And it could then be another FSP status variable request, so in which case you go back through the loop again, until you get to the point where not FSP status variable request is returned, in which case you go back into the flow as it had existed before. So then you go into the multi-phase, get number of phases, check if you've executed all the phases for the current component. If you have, you're done. If you haven't, you execute the next phase. And then that next phase could also potentially cause FSP status variable request to be returned. So this is kind of the new thing. So then you'd have to go back through the variables request servicing flow again. So once it's all done, you either continue on to temp/RAM exit or silicon init, depending upon your design. And for FSP-S, you just replace FSP memory init with FSP silicon init at the top and replace the bottom with FSP notify phase, and the diagram is the same. So finish off with our call to action. So first of all, please work on preparing for the new FSP 2.4 spec to come. So the spec is published and available now. We will use the new features of this spec in an upcoming Xeon design. So you should try to plan to have your bootloaders ready by next year. Second is we have Min platform available. As Isaac mentioned, it's open source. You can use it for your upcoming OCP design, and we'll implement all this FSP 2.4 support for you. Third is collaborate with us on new project opportunities. So we've been looking at converting some of the EDK2 core from C to Rust, for example, particularly security sensitive areas of the core. So that's one thing that would potentially be interesting to work on. We also have, of course, improving our Linux boot support in EDK2, as well as some of the other things like the QEMU starting, the AOWanda platform that was just added, and of course, the universal payload stuff. So most of our discussion on all this happens on the Tiana Core development mailing list. So if you haven't subscribed, please do so. And finally, we have some training material on Min platform for those who haven't used it before. And I think that's it. Do you have any questions?
Are there any EDK2 Tiana Core platforms that support FSP 2.4 yet?
Not yet. We have to release them with our silicon schedule. So once the new part that shows up that supports FSP 2.4 gets released, I can release it. But I'm not allowed to tell you what part that is. Or
You might backport
yeah.
it. I thought you might backport it to an existing platform so that people would be able to get familiar with it with an existing one.
That's an interesting request. We can consider it.
Right. Also, why isn't this FSP 3.0?
Because 3.0 is going to be something different.
All right, that's enough backward compatibility issues with 2.4 as it is. Okay.
Well, Technically, only if FSPI is there, right?
64-bit and 32-bit is not.
Fair enough, fair enough, yeah.
Hi, thanks for the talk. I got one addition and one question, basically. Addition is Quote supports already 64-bit, at least experimental support. So right now we're jumping back to 32-bit to run FSP for obvious reasons, but that is already there, so that we're kind of at least a little bit prepared for 2.4 changes. And my question is, with the discussion around the FSP specification, does this discussion happen on the Tianacom mailing list, or is that purely a closed discussion? So referencing to what ARM does is bringing that discussion around changing a specification into also into the open world, right? Is that something that you consider, or is that already happening somewhere?
So the FSP specification is an Intel-owned spec. So generally, the discussion on what new features to add happens at Intel, and perhaps with feedback from our customers.
Okay, thanks. Yeah. It's probably something to consider long term, especially if there are like major changes coming. That I think it would be good to include the community and like the people working on the project, basically.
Yeah, I think it's more just an artifact of there hasn't been discussions. Not that we're against having discussions. When it comes up on the Slack channels, Nate's there and things. So we're definitely open to talking about it in public. We're not intending it to be a proprietary process. It just happens to be because it's usually reactive to silicon changes.